Okay, so since I recorded this entire thing with no sound, we're going to go through it again, but I'm not going to work all the problems again. I'm just going to go through how I got them because I already did this one time. But up here is everything that y'all need to know for the entire unit. So this is PreAP Module 1 CBA review. So this is everything PreAP should have mastered by the end of Module 1. This is vocabulary that you don't have to have memorized. You don't even need to write it down, but it's good just to know the definitions to these. So if you don't know the definitions, make sure you ask in class before your CBA. Okay, number 1, the Venn diagram below shows the multiples less than 100 for 18 and 12. So I've circled multiples because it's important that you know that we're talking about multiples and not factors. Okay, less than 100 and then for 18 and 12. This one didn't have it labeled as some do normally, so this circle is representing 18, this circle is representing 12, and then the middle is your common multiples. Okay, so based on the information, which of the following statements are true? A says 72 is the greatest common factor. Well, we're dealing with multiples. We're not even dealing with factors. So that's a trick question because it's the least common multiple and it is common, but it's not a factor. So that would be incorrect. 2, 18 has 3 multiples less than 100. Well, 1, 2, 3, but we also have to count what's in the center. So that's 4 and 5. So that would be incorrect. Number 3, 36 is their least common multiple. That is correct. It's the smallest of the common multiples that they have. And then 4 says 60 would be the best common denominator for 1 18th and 1/12. The problem here is that 60 is not going to be the best because it's not common. It is just in the 12. So it's not in the middle. So it's not that common multiple. So there's actually not a correct answer on this one. It is just going to be 3 only would be your correct answer. Okay, number 2. The Venn diagram below shows the multiples less than 100 for 20 and 5. Again, we're talking about multiples, not factors. So I've got my 2 circles and then my common multiple in the middle. As you notice, this one is labeled 20 and 15, so it's easier to tell what's what. Based on the Venn diagram, which of the following statements is true? The least common multiple of 20 and 15 is 60. Well, that's true because it's the one in the middle. 20 and 15 only have one common multiple. There's only one in the middle, so that's still true too. And the overlapping area represents the common multiples. That's also true. So all 3 of them are true, 1, 2, and 3, which would be D. Number 3. The Venn diagram, it says below, but it's really above, shows the factors. So now we've switched. We're not talking about multiples anymore. We're talking about factors of 24 and 36. Based on the Venn diagram, which of the following statements are true? The greatest common factor of 24 and 36 is 12. Well, that's the common factor because it's in the middle and it is the largest one, so that's true. 2. 9 is a factor of 36 but not 24. That's true because it falls in the 36 bubble but not in the middle where they overlap. 3, 36 has more factors than 24. If we count the factors of 36, 1, 2, 3, but we also have to include what's in the middle. So 4, 5, 6, 7, 8, 9. So 36 has 9 factors. 24 has 1, 2, 3, 4, 5, 6, 7, 8. So it is true 36 has more. And number 4, 24 and 36 have 6 common factors. There are 6 in the middle, so that is true also. So 1, 2, 3, and 4 are all correct answers. So that would be D. Number 4, at the ballpark they are giving free baseballs to seat sections that are divisible by 2, 3, 6, and 9. So what I did up here was I wrote just little tips to remind me what the divisibility rules for 2, 3, 6, and 9 are. So divisibility rule for 2 is that it has to be even. For 3, it has to be the sum of the number divisible has to be divisible by 3. For 6, it has to be divisible by 2 and 3. And for 9, it has to be the sum of the numbers divisible by 9. Help the following families determine if they will receive a free baseball. So number 1 said the Snyders, a family of 7, not important, are seated in the section 264. So 264 is even, so it's by 2. If I add up 2 plus 6 plus 4, that's 12, which is divisible by 3. So it also is divisible by 3. And then because it's 2 and 3, it's divisible by 6. 12 is not divisible by 9, so it's not going to be divisible by 9. So that can't be our answer choice. They don't get a baseball. 2, Mr. and Mrs. Dooley are seated in section 162. Even, so it's 2. 6 plus 2 is 8 plus 1 is 9. 9 is divisible by 3, so that's divisible by 3. 2 and 3, which makes it divisible by 6. And then because it's 9, it's also divisible by 9. So Mr. and Mrs. Dooley are going to get a baseball. The Herdia family of 10 people, not important, are seated in sections 171. It's not even, so automatically we know this one's not going to work. If we kept going, it is divisible by 3 and it is divisible by 9. So the correct answer is 2 only. They're the only ones that will get a baseball. Number 5, which expression or expressions shows an equivalent expression using the commutative and associative property. This question is a little bit confusing because it wasn't really written well up here. I would say all of them are. The commutative property remembers that we change the order of the factors, or the add-ins in this case because it's addition. The associative means that we're going to change the grouping, so we're going to move our parentheses to a different set of numbers. As long as it's all multiplying and all dividing, you're allowed to do both of those. So for all of these, they would all work. Okay, here we have, between this one and this one, we've changed the order. Here we've changed the grouping. Here we've changed the grouping again. So I went ahead and put all of them. That's not my favorite question on this review, so if we need to go into that in more detail in class, we can. Of the following expressions, which shows the correctly written property? So again, associative, which I've written up here, is change the grouping, and commutative is change the order. So one is changing the order, which is commutative, and not associative, so that would be wrong. The identity property says if we multiply something by 1, we're going to get itself. So 2 would be correct. Number 3, we have changed the groupings, and that is the associative property, so as long as they're correct, that's going to be right. So 5 and 7 in one parenthesis, and 7 and 9 in the other parentheses, we've changed it, so that's good to go. Number 4, we're changing the grouping again, and we also have a difference of addition and multiplication, so that's not going to work for commutative property. So 2 and 3, which is A, is our correct answer. Number 7, which property or properties were used to simplify the below expression? Okay, so our expression is 2x plus 4 plus 5x. Don't let the x's freak you out. It's really not an important part of this problem. It's more just to see what happens. So from this step to this step, the order changes. Yes, we add grouping, but there was not an original grouping, so it's not going to be the associative property. It's just going to be the commutative property. We're just going to let it change places. So the correct answer would be A. Number 8. You're a math teacher who has assigned the following problems to your class. The work of 3 students is shown in the images below. Find out if each student answered the problem correctly. If a student didn't answer the problem correctly, write the student a note explaining what he or she did wrong. So Tyler did it exactly right, and it should be 2 to the 4th power times 5. He had his 2's on the side. He put his exponent correctly, multiplied by 5. Brandon, if you look when he did his prime factorization, he had that 8 was 4 times 4, which it's not. It's 4 times 2. So that affected his answer because he had two extra 2's here that he shouldn't have had. So when we cross those out, we then get 2 to the 4th times 5. Amy didn't circle the word prime. The word prime means that we can't have 10 because it is not a prime number. So if we broke our 10 down into 5 times 2, that would then give us 2 to the 4th times 5. 9. Freddie wants to determine if the following fractions are equivalent. Which of the following strategies could he use to determine if they are equivalent? This one doesn't actually have a correct answer, and it has to do with the wording of the problem. So, list the factors 6, 12, and 18 to determine the least common denominator. This would be correct if this said list the multiples. So if it says list the multiples for 6, 12, and 18 to determine the least common denominator, then that would be a correct answer. Okay, determine the denominator for the first fraction is proportional to the second one. That one's not important. List the numerators 1 through 5 and determine the least common denominator. Your numerators aren't going to help you determine your denominator, so that wouldn't be correct. List the multiples of 6, 12, and 18 to find the greatest common factor. If this had said list the multiples of 6, 12, and 18 to find the least common denominator, then that would have been a correct answer. So basically what we have to know with this problem is that you use multiples. You're going to find the multiples of your denominators to find your least common denominator, because your least common multiple of 6, 12, and 18 will be a denominator that they can all share. Number 10, order the steps for the following fractions to compare the following fractions: 1/4, 1/3, and 1/2. So the first thing I need to do, just like we set up here in number 9, is I need to list the multiples of 4, 3, and 2 to find the least common denominator. So that's going to be my step 1. Change each fraction to its equivalent fraction with the least common denominator. If you change the denominator, you have to change the numerator. That's just a golden rule for math, and you guys should have learned that when you learned to add and subtract fractions last year. So that's going to be my second step. And then my third step is going to be to order the fractions according to how they're asking. So I'm going to do step 2, step 1, and then step 3, which is B. Number 11. Leslie listed the greatest common factors of 6 and 18 as 3. Why is her answer incorrect? A says 3 is the least common multiple of 6 and 18. We're talking about factors. We're not talking about multiples, so that's not going to be the correct answer. B, 6 multiplied by 3 is 18. That's true, but it doesn't really have to do with this question, so that's not going to be correct. C, 3 is a factor of 6 but not 18. 3 times 6 is 18, so 3 and 6 would both be factors. D, 6 is the greatest common factor of 6 and 18. That is the correct answer. So it's not 3, it's actually 6. It's the greatest common factor. Number 12, the set of factors below show the common factors for which set of numbers. So we have 1, 2, 4, and 8. All of them are going to have 1 as a factor, and because they're all even, they're all going to have 2 as a factor. So I really need to look at which ones have 4 and 8 as a factor. So in letter A, 8 is good. 12 does not have 8 as a factor, so that's not going to be our answer. In B, 16 has 4 and 8. 32 has 4 and 8. 42 does not have 4 as a factor, so that's not going to be our answer. C, 8, 16, and 24 all have factors of 4 and 8. And then in D, 16 has 4 and 8, but 20 does not have 8 as a factor, so that's not going to be our answer. So our answer choice is going to be C. Alright, back to number 9, and this is 13, sorry. Did I skip one? Nope, that was 12. So, number 13. This is kind of where I was when I realized that it wasn't recording my voice. So, a math tutor has asked his 3 students to find the prime factorization of 200. He asked them to each explain his or her answer. Please circle the student's name as correct. So the first thing I did was I did the prime factorization for 200. So I worked out my factor tree, I got it all down to primes, and then I wrote it with my exponents. From there you can determine that Lauren is not right because Lauren is adding 2 to the third power plus 5 to the second power, and we need to multiply. So Lauren's answer is not going to be correct. Then I look at Rudy and Ashley, and they have the same answer, so I need to look at their explanations. Rudy says to multiply 2 times 3. That immediately is not going to be correct because with our exponents, 2 to the third power is 2 times 2 times 2, not 2 times 3. If we look down at Ashley's explanation, she says multiply 2 times 2 times 2, which equals 8, then multiply 5 times 5, then multiply your products together. Okay, that's what we need to do. Rudy up here also said multiply 5 times 2, which is not correct. So Ashley would have had the correct answer. Number 14, Marco is in elementary school. His father is 30 years older than Marco, and his mother is 4 years younger than his father. The ages of Marco, his mother, and his father are all prime numbers. What are their ages? So the first thing I'm going to do to solve this problem is I'm going to write the common ages of an elementary school student. So they start at about 5, 6, 7, 8, 9, 10, and 11. Okay, once you hit 12, that's when you're heading to middle school, and even 11, but we're still going to leave it. The second thing I'm going to do is I'm going to cross out the numbers that aren't prime because it said that Marco's age has to be prime. So 10 is not prime, 9 is not prime, 8 is not prime, and 6 is not prime. So I'm left with 5, 7, and 11. So now I know his father is 30 years older than him, but his age also has to be prime. So 5 plus 30 is going to be 35. 35 is not a prime number, so 5 can't be my answer. Okay, 7 plus 30 is 37. 37 is prime, so that could be my answer. And then 11 plus 30 is 41, which is also prime, so that could be my answer. So both 37 or 41 could be one of my answers. So now what I need to do is I need to subtract 4 from these numbers because his mother is 4 years younger. So I need to do that and make sure that that number is still prime because if it's not prime, it's not going to be our answer. So 37 minus 4 is going to be 33, and 33, though sometimes we might think it's prime, it's not prime because it can be multiplied by 1 and 33 and 11 and 3. So 7 cannot be my answer because this is not prime. Okay, 41 minus 4, when I subtract that, I'm going to get 37. 37 is a prime number, so Marco is going to be 11 years old. Alright, last problem, number 15. The statements below are all false statements. They're all false. Give an example to show why each statement is not correct. So the product of 2 prime numbers is always prime. Well, I'm just going to pick 2 prime numbers, 5 plus 7, those equal 12. 12 is not a prime number. So that would be incorrect. When a composite number is the dividend and a prime number is the divisor, the quotient will never be a prime number. So I'm going to do 35 divided by 5. And when I divide that, I get 7. 7 is prime. So that is not true. The sum of 2 composite numbers is never a prime number. 4 plus 9, both of those are composite. That equals 13, which is prime. And finally, the difference of 2 prime numbers is always a prime number. Okay, 13 minus 7, both of those are prime, equals 6, which is not prime. So that would also be false. Okay, so that is the PreAP Module 1 CBA review. If you guys have any questions, make sure you come into tutorials before your CBA on Friday, and I wish you all the best of luck.